Welcome back. Let's talk about rotations. Rotations is another technique for determining the true shape of an oblique surface. It's similar to auxiliary views, but not exactly the same. So here I've got a step-by-step process kind of drawn for you, and I'd like you to just follow that. So let's kind of go through what we're going to do. So first you're going to start with a three-view ortho of our little block with an oblique plane in it. We've seen this in a previous assignment. You're going to take the top view here and rotate it over this way such that this line is vertical. Right, and then from that you'll project down and then through a 45-degree line into the front view and the end view. All right, and you'll use that to reconstruct the front view and the end view, or you could also say the side view. All right, and then once you've got those done, you're going to take the complete front view and turn it such that this edge is straight up and down. And then you'll take these projection lines from before and move them down into here. You'll take the rotated front view and project up into those lines and then over into these lines. And you can use that to construct the rotated, final views. And in this, right in here is the shape of our true surface that we're interested in. Okay, so that's the steps that you're going to take, and I'd just like you to follow these step 1, step 2, step 3, step 4 process. I'll draw this for you in a second, but before I do that, let me show you another tool that is pretty useful for demonstrating why this works. So this is Rhino. It's a 3D modeling tool. Now here I've got the top view, and if I grab it and start rotating it, observe what's happening to the front and the side view. The heights are staying the same. Okay? So if I lock the top view down such that that edge is vertical, and then come over to the front view and start rotating it, then observe what happens to the top view and the right view. The top view is staying the same vertical height, right? The vertical height stays the same, and the right view is staying the same horizontal distance. Okay, that's just what happens when you do these rotations on a 3D object and you look at the orthographic projections. So that's kind of the theory or the concept of why this thing works. And when we're done rotating the top view and then rotating the front view, the Rhino, well, this is Rhino, but the oblique surface will be in the plane of the paper. We'll be seeing the true shape of the surface. All right, so Rhino does this all for you. You may be asking, well, why can't we just use a tool like that? Well, that's simple answer is that's too easy. But the true answer is that we want to do this projection stuff. This projecting into different views and all of that. That is just a really good general purpose problem solving technique for useful in design. All right. Sometimes you just need to project things on a flat piece of paper. 3D tools are great, and we'll be using those, but this is also another good tool. All right. So let me go ahead and draw these things. I'm just going to follow these. Step 1, step 2, step 3, steps 4. All right, okay. So I've got AutoCAD up, and I've got our little friend here, the oblique block with the block with the oblique plane. Okay, so first thing we're going to do is take this block and do a copy, and just move him kind of over right about here. Then select the copy and do a rotate, and the rotation point is this point, and you want to rotate with reference. So center, end point, and then press F8, turn ortho on, and click to get that guy pointing straight up. Now I'm going to move him down a little bit. Right about there. All right. Now generate some projection lines. Come off of all of, whoops, let me switch to hairline lines here. So take all of these points, and I'm just leaving ortho on so I can draw these guys straight out. So get all of these guys. There's only 3 lines that we need, that we can project. Okay, then draw a 45-degree line about like that, and then project. Now turn ortho back on and project from each one of these points. Make sure you get them all. Like that. And then, did I get them all? 1, 2, yeah, I think so. Then from these points, come on down with, once again with ortho on. Come down from the 45-degree intersections, and then come down from the object itself. Okay, so somewhere in this grid is our front view, and somewhere in this grid is our side view. So I'm going to go ahead and trim these guys and these guys. I really like the way they fixed up trim in this version of AutoCAD. Okay, so I'm going to switch to red heavy. So somewhere in here is our object, and this is just something you have to visualize. Now I've given you the solution, and it's totally fine to kind of, you know, use the solution that I've given you as the guide, because it's not really easy to do this, but you should start to kind of see the thing as you guess and check your way through this. So there's going to be a line there, and I'll kind of point out some things as I get this guy drawn. Let's see, this comes down to this point, you think? And that makes sense, right? And across the bottom, then there's going to be a line here that's going to be hidden because that's on the back side of the object in the top view. And I'll change that to hidden while I'm thinking about it. Then there's going to be a solid line. There's going to be a solid line right there. That's this this point right in here, which in the top view is there's a line going down, like perpendicular to the paper in the top view, if you want to think about it that way. Shows up as a straight line here, and that's that view. That's done. The side view, let's see, the side view across the bottom is flat all the way out to there, right? That much is the easiest thing to think about. And let's see, this back corner here comes all the way up, and that would come to there. And let's see, then it gets a little bit harder. And this in here, there's that edge, which is, oh, I missed a point. I missed a line. Let me go back. I missed a line. I missed a point from here down. Yeah. Back to red now. I really need a macro to switch these line colors. Let's see. This thing comes over. It's going to be that one, right? Just tracing your way up through these things. It's over there. And then here, let's see. It's going to come to there and then straight down, because the length of this one is the same as the length of this one. If you agree with that. Then this guy's going to come down to this corner, right? Because if you trace back up, it comes back to this back corner over here. So that'll be over right there. And then this guy will come, could be this one. Could be that one. What do you think? This one? Yeah, that one. Then there's a line. This back edge in here shows up as a line here, right? Because if you trace this back through here, you come to this point in the corner there. So that means this is a line in the back. It's and it's hidden. So it's visualization. It's the graphics processor in your head. You need to, you need to visualize the object in your head and somehow get that out on the paper. And guess and check is probably the best thing to do, because when you have it right, your brain will recognize it, just like you recognize a face. So start drawing some lines and move them around until the visual part of your brain says, yeah, that's okay. Okay, that's that. Is there a line here, you think? No, I don't think so. All right, that was the first rotation. We took the top view and we turned it up like thus. All right, now what we're going to do is we're going to take these projection lines right here, all of those, and copy them down somewhere, like there is good. Then take the rotated or the front view from the first rotation. So this up here is all the first rotation. We'll take the front view from that and copy it and put it right. We'll put it right here. Then I'm going to do a couple stretches. I want to make sure I have ortho, so I pull these straight down. Then another stretch. And pull these over this way. Okay. The reason we copied these lines here from up here is because those dimensions stay the same. The side to side stays the same in this view, and the up and down stays the same in this view. That is, they stay the same while this thing is going to rotate. Think back to that video I was showing you a moment ago from Rhino. So now we're going to take this guy and rotate it about this point, and we want to do reference and center point, first reference point. Then with ortho on, it'll snap up like that. Okay, now you can grab it and just do a move and bring him down so he's not in the projection lines. Okay, now it's time for a bunch more projections. So we got to go back to plain old lines here. POLs, plain old lines. Then start taking each one of these points, and you could snap perp, or you could just with ortho you could draw past. I'll go ahead and snap perp. Make sure you don't miss any of these guys. Okay, this line here, it's happens to line up with this other point for my block, but it might not for yours, and that's because there's different ways to draw these original blocks. That is, I made mine 1 inch wide and 3/4 high. So I have to have 3/4 here, and I have to have 3/4 here, and then the inch wide I have to have 1 inch here. The three views have to agree with each other, but it is possible to draw this block a little bit wider or a little bit higher, as long as your three views agree. So if you draw yours with slightly different dimensions, you may not have things line up. Mine just happened to line up because of the dimensions that I chose. Mathematically, they line up exactly, but it's a chance. All right. So that's those projection lines. Then I got to project horizontally over to these guys. Projection, it's good stuff. The other reason to understand this is, let's say you don't become a designer. Let's say you switch your major to work on graphics cards or something. Then you're going to be writing code that does this kind of thing. So of course that'll be code, but having done it manually once would really help. Let me trim these guys up. Whoops. Trim, enter. Okay. All right. Did I get all the lines? All the points? So I'm going to switch to red now. I got them all. All right. Now we'll switch to red and see if we can fish this guy out of the mess here. Okay. Lucky for me, I have the answer, but let's see if we can make sense of this thing. I guess the best way to think about this is if you go back to this first rotation and you imagine turning this guy such that this line is vertical. What does that do to the top view? Basically, it takes this point and turns it, the point in here, it turns that into a line. If you can imagine this whole thing, turning about this as an axis, right? Imagine this whole block here rotating about this axis. Then this point will become a line. The point in there will become a line, and the point, the 2 points. There's 2 points in here. They become a line. There's 2 points on top of each other that become a line, and there's 2 points. There's 2 points in here on top of each other that become a line. That's probably the best way to think about it. And this back edge will give you the start and stop of one of those lines. So I'm going to guess here that sort of guess and check. It's going to be on this guy, right? This point in here will become a line stretched out along this line, lining up with these two guys. Okay, so there's a right there in here there's a line. So right in here there's a line. Right there. Let me check that. This guy, and these two guys. That's the first one. Okay, now the point up here will stretch into a line as this guy rotates. So, and that's going to be, where's that going to be? This guy. Yep. Because this hidden line is, see it's here. It's lined up with this point up in here, and so these two lines here that come off of that hidden line, they sort of bound the location of the of this line that's up in here. So there's a line here, basically. Okay, great. Then the point here is going to turn into a line. That point lines up with this line, which gives you these two boundaries, or rather these two boundaries. Excuse me. So the intersection of those two lines with that, okay, which corresponds to this junk up in here. If you can see that. It's not easy to see that, but that's why I gave you the solution, because this is hard. I totally realize that this is not easy to see. Once you have those, then you can sort of, oh, this is not right. These two are parallel, right? And they should be, but these two should be parallel, right? It's because this one, there's a notch there. This notch you don't really see because it ends up kind of all on this stuff in here. In other words, there's a line kind of here, but it's really two different lines. Like you could, let me do that again. Like it might make more sense to you to realize that there's a line from here to here that's kind of coming, you know, sloped down into the paper, so to speak, and then there's another line here that's sloped kind of the other way into the paper, if that makes any sense. One of these is yeah, I mean, this line here becomes this line, and then this line, or here, I'll draw it real quick. This line here kind of becomes this line. As like, you can sort of imagine this point here kind of was there, and now it moves over here. Stuff like that. So try and visualize what the heck's happening there. Anyway, that's that one. All right, let's do the one in here, which is the answer we're seeking. So I think the easiest way to draw this view is to realize that back in this view up here, we have a line here, and a line here, and a line here, which are going to kind of move vertically as this view turns, right? As once again, as this view here rotates up into this position, this line's going to shift vertically, and this guy's going to shift vertically, and this guy's going to shift vertically. So those three lines here are somewhere on these three lines. And where are they? Well, this one locates the hidden line, right? And this corresponds to the hidden line. So there's a line right there. Let me draw it. There's a line right here. Okay, then this one moves somewhere. It moves vertically somewhere onto there. And that's the line on, wait, I think I did that wrong. This guy here, I don't think he's there. I think he's over here. Because that's the line on the back side. This line is on the back. When you rotate the top view to get this front view, this hidden line, that's its match right there. So yeah, it's over here. Likewise, this guy represents this guy, which is on this line between, I forgot a projection line. Let's get that projection line in there. Right here. Yeah. Yep. So back to red. Okay. This guy corresponds to this guy, which is on this guy between these two guys. So there's a line right here. Here to here, there's a line. Then by that same kind of thinking, this line corresponds to this line, which is on this line between this line and this line. So there's a line right here. So that's kind of tricky, but that's those three lines. Now, this box only has 3 of those kind of lines, because the last one is a point. In this, right in this little box right here, that's a point. So that projects over to here and down to here, and it kind of disappears when you get in here. You don't see it, but it's still there. It's just lined up with all of this junk. So there's a point on that, basically, at this point down at the bottom here. So that tells us that these guys connect down to that, basically. There's other ways to kind of fish this junk out of here, and, you know, use whatever is working for you. But it's starting to be visual. You can see it now, right? And there's some, you're going to have parallelograms. So some stuff, like, I know that the line coming down from in here somewhere has got to be parallel to this guy right there. So I'll take this guy and copy him from here to here. Yeah. Now what do? There's some weirdness going on in here. You got to stare at this for a second. Okay, I paused it and I stared at it, and that's what you need to do. You just need to stare at it. Look, in this parallelogram right in here, the corner should be cut off. So, like that. Yes? I mean, I have kind of those two are parallel, and that would make a parallelogram, but with the corner cut off. So I gotta cut that like that. Basically, that's the edge of the box that. This is the edge of the box that you know, has a corner cut off. So now all I got to do is connect these other dots. That turns out to be horizontal. How interesting. And then this one's there, and then, you know, that's it, right? Then that guy, that guy, that guy are hidden. Yeah, we did it. That's it. Here's our answer. This thing, maybe I'll make it green because it's the answer, so it jumps out at you. There it is. Okay, so not, you know, not trivial. It's some pretty good spatial workout here for your brains. Guess and check, follow the process. So once again, I've got this step-by-step kind of thing. Follow that. And if you want to make it look this organized at the end, that's cool. But at the very, you don't necessarily have to. Just what I really want to see is something that looks kind of like what I got right here. Okay? So that's that one. All right, have fun with that. I'll see you next time.